Hello everyone, and thank you for joining the second week of the Signal Center's Accessibility Awareness Series. Signal Centers is located in Chattanooga, Tennessee, a gig city on the Tennessee River, and ranked as one of 2019's top 100 places to live in America. Signal Centers provides technology, accommodations, and training to help individuals with disabilities live their best lives. Here is CEO Donna McConico.
Hi, I'm Donna McConico. Welcome to the Signal Center's Accessibility Awareness Summit. Last year, at our very first summit, our keynote speaker, Haben Girma, said this: "The problem is never the disability." She was right. We are living in the midst of a technology renaissance, and we must be the leaders insisting that this movement is for all. Accessibility is within our reach, and it will take persistence and creativity to fully embrace all of the possibilities that technology offers for individuals with disabilities. Thank you for joining us again this year to continue the conversation about accessibility.
This webinar series would not be possible without the support of our partner and host, Chattanooga State Community College. With an enrollment of more than 8,000 students, Chattanooga State offers more than 100 degree plans. Its digital accessibility mission statement is a commitment to provide all individuals the opportunity to use technologies. Here is Vice President of Academic Affairs, Dr. Beth Norton.
Chattanooga State hopes this conference series will inspire transformative conversations about the inclusion of all individuals in the ever-changing world of digital technology.
Signal Centers is grateful to the following sponsors: McKee Bakery, Blue Cross Blue Shield of Tennessee, Unum, Electric Power Board, Tennessee Council on Developmental Disabilities, AT&T, and a special thank you to Phil Hour for sponsoring today's sessions. If you require sign language interpreting for today's sessions, we recommend you setting your video display to Grid View, which can be found in the upper right-hand corner of your screen. At any time during today's session, you can return to these options to customize your view to your specific need. If you require captioning, please make sure your Multimedia Viewer panel is enabled on the right side of your screen. And now, in recognition of Global Accessibility Awareness Day, Artificial Intelligence and Emerging Technologies, Clinic Manager and Residency Director for Orthotics and Prosthetics, Chris Fink, and Research and Design Engineer involved with prototyping prosthetics, Brian Cuervo.
Good afternoon, everyone. Thanks for joining the session. I am Chris Fink, and so as a prosthetist orthotist, what I do is I see patients on a daily basis and help them achieve kind of their goals. And so kind of put together a presentation here on the emerging technologies in prosthetics and orthotics and what we should see here in the future. So for those of you who don't know, what is prosthetics and orthotics? Let's start there. Prosthetics are basically devices that are designed to replace a missing body part. So you can think arm, leg, foot, anything like that. While orthotics are devices that use to support the body due to some kind of weakness, injury, deformity, and you can kind of see some examples there. We also kind of wanted to define what is emerging technologies. So for this presentation, I've defined that as any kind of new technology that's being developed in the next 5-10 years. And it also has to provide a substantial or significant impact on the business or the field. I've expanded that a little bit to include some other things, talking about continuing development of existing technology or technology that has potential that has yet to be realized or embraced by the community. So a great idea or a great example of this was, say, cell phones. 15, 20 years ago, they were used by some, but not to the level that they're used today. So it was a technology that was out there, but now has totally exploded into a whole new realm. And so in prosthetics and orthotics, what do we try to do? We look at modifying the person and not their environment. So a lot of times when you look at disabilities in the workplace, we look at, people are looking at how do we change the environment or physical space that they work in. We're looking at modifying the person to help them adapt and be as comfortable and productive in their environment that they are. So whether that's through orthotics or prosthetics, that's what we're trying to do. So in emerging technology in P&O, I've broken it down into 3 general areas. There's a ton of different stuff that we could look at, but I looked at 3 for today. We're looking at externally powered devices, device control and feedback, as well as some surgical procedures. Inside of externally powered devices, we'll break it down into 3 areas. Exoskeletons, which are a big buzzword and people talk about all the time. You see them on the news and social media. Power generating prosthetics, those 2 are kind of out there and seen a lot, and upper limb prosthetics. When we look at exoskeletons, we can use those, and those can vary from different musculoskeletal disorders to even military applications or things for industrial applications as well. They can be for different body segments, so just the upper body, just the lower body, or the whole entire body itself. And while they have been around for decades now, they've had really limited use due to cost of the devices as well as comfort while wearing them. And comfort is a big one for these devices. As with any new technology, cost is coming down quite a bit. The comfort issue has been for a long time the biggest hurdle to get by. And there are a couple of research groups out there that are getting really, really close to figuring out the comfort issue and being able to have devices that you could wear basically full time all day long. So on the left, you can see kind of an industrial application there. It's an upper body only kind of system. That's a commercially available system used to reduce the stress on the upper body joints. So somebody could be weak or just trying to reduce it for a population that doesn't have any weakness. The middle one there is someone with something maybe similar to a spinal cord injury. They're helping that person walk, stand for prolonged periods of time that they might not be able to do at all or is very, very difficult without the devices. On the right, you can see military applications. So those are exoskeletons trying to increase the load or distances that our military personnel can walk, carrying something or heavy loads and things like that. So all different kind of realm as far as exoskeletons go that we can see. When we look at power generating prosthetics, if we talk about a typical lower extremity prosthesis or artificial limb, most of them do not have any type of power source. So they're not connected to a battery or anything. They're glorified springs. Some prostheses out there use batteries to operate microprocessors that open and close valves. But very, very few, and you can see 2 examples there on the left, actually produce power. So actually have motors in them that are driving pistons and different mechanisms to actually produce power. The 2 on the right are 2 that are kind of in a research phase out of Vanderbilt and Georgia Tech. And the whole idea behind these type of prostheses is walking with a traditional prosthesis, we'll see anywhere from 2, 3, 4 times the amount of energy expenditure that an able-bodied person would use. And so the idea behind a power-generating prosthesis is to reduce that amount of energy that it takes to complete a task or walk or stand, to allow these patients to go back to a normal physiological level of ambulation and completion activities. So this can take patients to being able to complete a full day of work versus when they couldn't because of different issues and things like that. So next, upper limb prosthetics. And I tell people, some people consider me an upper limb prosthetic expert, and I could spend all day talking about upper limb prosthetics, but we'll go on and just hit on a couple different things here. As far as the new kind of emerging things, if we talk to patients, the whole issue with these highly complex upper limb prosthetics is that they haven't been very durable, and they have had issues with water until very recently with the Tasca hand and the electric hook that you see there. Water was the enemy. I tell people it's the same kind of thing. I hate to use cell phone reference for everything, but you couldn't drop it and you couldn't get it wet, just like cell phones a few years ago. Now with these devices, they can be dropped, they can be pushed on, pulled on, yanked on, pick up heavier loads, and they can get wet. They're waterproof. That's huge for an amputee. You're talking about activities like bathing a child, doing dishes, washing a car, all those things that previously they couldn't do that are now basically opened and removing these limitations to these patients. So all these that you see here are commercially available, been fitting on patients for years now, but it's still not fully adapted and accepted by the field as much as it probably should be. In our next section, we want to talk about device control and feedback. We're going to talk about pattern recognition, which is a means in which we can control a prosthesis. Implanted sensors, both in the limb and the brain, that can provide control of a device. And then we have sensory feedback, which can be built into devices and other tasks. So with pattern recognition, like I said, it's how we can control limb. A little bit of background in normal prosthetic control, and specifically the upper limb kind of control, but this can be used in lower limb devices as well. As we used to have two sites, two sensors that would pick up muscle signals in the arm. And one would tell a device to open, and one would tell a device to close. Keep it very simple. Pattern recognition is using multiple sensors, usually about 8. More or less than that has been shown too, but 8 seems to be the magical number. And we're picking up a lot of different signals. When we had the traditional 2-site or 2-sensor control, it wasn't very intuitive for a patient. They kind of had to do motions and fire muscles that didn't really make sense to them to make a hand open and close. With pattern recognition, I simply ask patients, do whatever you feel opens your hand, and they make that muscle. And the computer system records that. And do whatever motion you feel closes your hand. They do that, the system records it. And then that is programming that device to work in that manner every single time. So it gives patients a lot more intuitive control to what they're doing, and can make multiple grip patterns, multiple more complex type of graspings very, very easy and intuitive for the patient to complete. Some people will call this artificial intelligence, machine learning. Those are kind of the buzzwords. Pattern recognition is kind of what we notice it as and talk about it in the field itself. Another really, really cool thing, and just in the infancy of development, are these implanted sensors. While currently external sensors are what are used at all times, implanted sensors are going to allow us to sense muscle signals that were not necessarily detectable previously. So currently we have to go through muscle, fat, all these other things, and skin in your arm when we use an external sensor. An implanted sensor can be directed directly towards the muscle that we want to sense. So the muscles that were remaining in the arm that used to operate fingers, hands, wrists, anything like that, I can put it directly into that muscle, and we can get a much more cleaner, precise signal compared to an external sensor. Not only can we place these in external muscles, but these can be placed in the brain as well. This has a great impact on the spinal cord injury population. So those whose muscles might not be working properly or might not be fully connected, they can then, instead of operating a prosthetic device on the end of their limb, could operate a robotic device within their house to help them grasp different objects, complete different ADLs and things around their home, or even in the workplace could have some type of robotic attachment that looks a lot and works a lot like a prosthetic arm or hand, but is, since they have full motion of their, or full ability to have their limbs, that they can use some type of robotic attachment or even orthosis. Sensory feedback is another one of those areas that's just in its infancy as far as what we see, but has its first recently launched commercially available product that you see there on the left, which is a hand that has sensory feedback built into it. Now this allows users to know when they've grasped something, how hard they've grasped something. It's a really kind of closing the loop as far as prosthetics and orthotics goes. So prior to this, patients didn't really know if they grasp something, how hard they're grasping something, if it's slipping out of their hand while they're doing it. So this, like I said, closes the loop for patients. And they're not only doing this externally, so the one on the left has a vibration kind of sensor that the patient will learn what those vibrations mean, but they have internal sensors that are in research phases now that are actually connecting directly back to the nerves in the arm that originally were responsible for sensation. Initial studies in this are showing patients able to complete tasks with a much better results as far as speed and accuracy. So they can tell when they're grasping things, how hard they're grasping things, and can complete simple tasks, say moving blocks from one dish to another at a much higher rate and much more accurate rate. Lastly, I want to talk about some surgical procedures. While as a prosthetist, I don't perform surgery directly, surgical procedures are one of the biggest things that affect the ability for a prosthetic user on the end and can affect the way I can fit a prosthesis, or if I can even fit a prosthesis. The two surgical procedures that we're going to look at are osseointegration and TMR and RPNI. TMR is targeted muscle reinnervation, and RPNI is regenerative peripheral nerve interfaces. While they are very different to a surgeon, they have some similar uses as far as what we're doing prosthetically. Prior amputation techniques, to talk about them, when there was a nerve and we had an amputation, the nerve would simply be severed, would be cut, and we would just place it randomly in the rest of the limb. So just somewhere under muscle and fat. It wouldn't be reconnected to anything. It's just kind of floating in space. The problem with this is that a lot of times this can develop a neuroma. Neuromas are very painful, kind of inflamed ends of nerves. And it's a fairly frequent and common issue with amputees. This can be from the low end of just an annoyance to a patient to, on the high end, a limiter and that they can't wear their prosthesis at all, or for very short periods of time. So it can take somebody who would be ambulatory or user of upper limb prostheses to non-ambulatory or not able to use their prosthesis. What TMR and RPNI do is they look to reconnect those nerves to actual segments of muscle. And what they found is by connecting these back, giving these nerves a home that they're used to, not only do the formation of neuromas pretty much go away and nerve pain pretty much is eliminated, we can now use those segments to actually put an electrode on those muscles that nerve is now connected to and control a prosthesis with them, or an orthosis, or a robotic kind of device. And we can now get even better control. So these are all the nerves that used to go to the hands, the fingers, everything that used to be amputated, or the feet or the knee, everything that was amputated, those nerves are still there. And as long as we can track which one does which, we can get the control back from it. So it's really, really exciting. I tell people it's a win-win, less pain and better control. It's kind of the best of both worlds. Osseointegration, a lot of people have probably heard that word or might have heard that word. We're looking at a direct implant of a titanium implant into the bone. Traditionally, we fit sockets around the limb, and now with osseointegration, which is just starting clinical trials here, but it's been in practice around the world for close to a decade now, I want to say. This prosthesis, instead of having a socket that goes on the limb, causing heat, discomfort, pressure, friction, all these things that are not very comfortable, we connect directly to the bone through a titanium implant, and we eliminate the problems from the socket. So this could lead to a lot of patients being able to stand, walk, work longer, and not have to remove their prosthesis from time to time throughout the day. It also eliminates a lot of the times of when patients have to see us. So most of the time when a patient sees me, it's for an adjustment to their socket because it's not fitting correctly, or they're sweating, or they're having all these other issues. So it's a lot more time back at work or at home with family, friends, and not having to see a prosthetist or a medical expert. So with that, people always ask me, what is the future? And I tell the future is full of possibilities. We're at this time in technology that anything is possible, absolutely anything, and just a matter of if you can dream it, we can kind of build it. Now with that, I want to play this short video here, and this is really, really cool. It's out of Europe, Sweden, and this was released just about a month ago. And what this is a combination of a lot of the things that we just talked about. So this is an osseointegrated prosthesis that has internal sensors with implanted electrodes and sensory feedback. The coolest thing about this is all the wires and sensors pass directly through that titanium feedback. So there's nothing external, nothing getting caught. We don't have to worry about Bluetooth or any technology like that. So what you can notice is just how intuitive, easy these patients are using these devices. And so it's just a really great future look at what the field of prosthetics is going to look like in the very, very near future. So with that, I'm going to let Brian talk a little bit about the engineering side and how we get to these devices.
Hi, my name is Brian Cuervo. I'm a research and design engineer for Phil Auer in Chattanooga. And I'll be going over a few things this afternoon. I'll be discussing engineering, design for disability in the workplace, a few of the tools of the trade that I use to get my job done. And along with that, there is outsourcing and collaboration, how we use the resources from other companies to produce and research and create new designs. And I'll get into the new field that's really interesting of mechatronics and the Internet of Things that you guys may have heard about, the IoT. Then we'll come full circle and go over how all of this makes life easier for patients with disability in the workplace. Now, as far as disability in the workplace, there's a variety of needs and a variety of jobs patients with disabilities have. It can go from anywhere from office work in a low stress, not a low mental stress, but a low physical stress environment. It can go to something on the right-hand picture where you're a very physical employee doing manual labor. The prosthetics on the right view are Hosmer hooks that we make at Phil Auer. And we have a coworker that uses one of these hooks in one of his upper extremities. And he does physical labor every day at Phil Auer, working in the central fabrication department. And it's really amazing to see this guy work because he's doing hammering, he's machining parts together, he's fastening parts together, sanding, filing parts, screwing parts together with one good hand and with one of these Hosmer hooks in the other. And you really can't tell that he has a disability at all. It comes from lots of man-hour uses and just really fine-tuning the prosthetic for the patient. So in my field, how would I go about designing one of these products? Let's take the Hosmer hook on the right. One of the main tools I use as an engineer is CAD, or Computer Aided Design. So in CAD, what I can do is create products. For example, the components that comprise a Hosmer hook. On the left-hand side, you have parts. So I can design these parts to be any shape. They can be any size, any color I like, any texture. And I can even give these virtual parts properties. For example, I can make this part out of aluminum or titanium or stainless steel in the virtual world in this program. And when the program knows these properties, I can actually test these properties to see how strong the part is. And I can even figure out what the weight is. That's a critical thing for patients with disability, to have preferably the lightest prosthetic or orthotic possible. So once I have one part designed, I can make other parts and join these parts. For example, a Hosmer hook has 3 basic components, 2 hook parts and 1 fastener. And in CAD, or Computer Aided Design, I can join all 3 parts and make a functioning virtual prototype that I could actually open and close in my CAD program. And once I finally come up with that design I like, I can communicate with the machine department to produce this part by creating a print or a drawing. For example, here's a print of one of the parts of the Hosmer hook that gives dimensions. And once the machinist has these dimensions and has the CAD file, I can use CAM, or Computer Aided Manufacturing, to hand off the information to the machinist in our machine shop to produce a part, prototype or production parts. In this case, I'm showing a Haas CNC machine. These are very huge machines that can mill out practically any design you like, out of practically any material that you choose. But the key thing here is, if you look in the upper right-hand corner of this Haas machine, being a CNC machine, this is almost completely controlled by a computer. CNC is computer numerical control. So I can give the machinist my models and my drawings. He inputs the information into these machines, and almost hands-free, these machines can create parts. You can see in the right-hand picture a milling bit, and how the machine can mill from a billet, or a volume of aluminum in this case, to make a part. So what do I give these guys to make parts with? Well, I could give them different types of metals, like titanium. From my viewpoint, titanium is a good material to use. It's a strong material. It's tough. It's relatively light. But again, there's always trade-offs. The drawback for titanium is it's not cheap and it's not easy to machine. A lot of this stuff is not really emerging technology. It's kind of been around for a while, but it's relatively new. For example, the titanium and composite materials like this center image, that's from carbon fiber. Composite materials are great for forming complex shapes. They're used at Fill-Out for making sockets and for making different kinds of orthotic devices. And another material that we commonly use, you guys probably recognize what the lower right-hand picture is. Good old Legos. Legos are made from a nice engineering plastic called ABS. So if they're durable enough for kids to handle, they're pretty good for orthotics and prosthetics too. So this ABS material can even be used in one of my favorite tools, good old 3D printer. This is one that I have in-house that I can use to make prototypes with. And I'll use a thin extrusion of this, in this case ABS material, to make prototypes that I can play around with in-house after I design the virtual prototype in my CAD design. And you really can't use this kind of prototype for production use or for testing on a patient, but it gives me something I can get my hands onto to get a feel for how parts really fit together and to get an idea of kind of how the strengths will be for given parts and assemblies. For production use, they do have really nice advanced 3D printing machines. All these 3D printing machines, which are relatively new emerging technology, are additive machining processes. So we're not taking a billet or a solid volume of material like with the CNC machine I showed you earlier. These machines actually create, I would say from nothing, but really not, but actually kind of from nothing, they add to a base or fuse powders together to make a final product. These machines, like the HP multi-jet fusion machine, can make production parts, very strong production parts, larger than my hobby grade 3D printing machine. And they can make relatively quicker production parts because 3D printing tends to be slow. And they can use different materials than I can. Some of these machines can even use metals and create 3D printed metal parts, which is pretty amazing. They can even make jet engine parts from 3D printing, which takes a high degree of a very specific tolerance, high degree of accuracy. And these 3D printing machines can do that. Now moving on to collaboration and outsourcing. These machines, for example, the HP, like I mentioned, are not cheap. They're not small machines. They need a kind of a dedicated room to use, and they need specialized technicians to use this equipment. So if we could find a company that could maybe have a bank of HP printers and have different resources that they could use that we could collaborate with. For example, they may have injection molding machines where you're actually injecting hot plastics like that ABS plastic to make molded parts. They may have access to or may have in-house sheet metal fabrication machines, or something that we have, I showed you earlier, the CNC machines, or 3D printing. And there's all different kinds of 3D printing machines, CNC machines, injection molding machines. If we could collaborate and use these companies where myself as a design engineer could simply give them a file. And again, these CAD production parts in the virtual world are just files in my computer. And I could send them through the World Wide Web to the internet. To the company, they could make prototypes for me to test, and the turnaround time is a matter of days. Or they can make actual prototypes. So these companies have a vast resource, vast array of machines. And they may just have all these machines in-house, or they may outsource to other companies that specialize maybe a specific machine, like 3D printers. So you can imagine that one company like us, we certainly can't have a huge warehouse full of CNC machines at our beck and call, or a huge warehouse of different types of 3D printing machines, but these companies can. So you'll see on the left-hand side, Haas CNC machines, and on the right-hand side, the HP multi-jet printing machines. So this is really an emerging technology that we really take advantage of, where we can preferably use another company's specialized resources outside of our company to make prototypes and make production parts. Now moving on to mechatronics and the IoT, or Internet of Things. Mechatronics is a combination of a couple words, mechanics and electronics. So any of these devices that are externally powered, prosthetic hands or prosthetic legs, all involve mechatronics or robotics. They involve the mechanics of the individual joints that move through gears, joints, pulleys, and the electronics that move these parts through wires and batteries and microcontrollers. And the name of the game for these prosthetics is size and power. You want something minimum size to take the same volume that a hand or a leg or an upper arm or a lower extremity would take. And ideally, you want, in that small size, you want maximum power. You want lots of force, torque, and you want it to last a long time. So that's a real challenge for a design engineer, to produce a prosthesis that can do the best of both worlds. Something with lots of power, lots of use for throughout the day use, and something in a compact size. We can get there, close to getting there these days, by using a few new technologies like neodymium magnets on the left-hand side. And again, if your children like certain toys to play with, like your vector sets, they may have some magnets attached to little plastic rods. And these really powerful tiny magnets can be used to make little tinker toys or vector sets. For prosthetics, these same magnets can be used in motors to make very powerful motors. Chris was talking about the use of phones. A lot of the engineering that's gone into phones has trickled down into high tech for prosthetics. And one of the big ones is lithium polymer batteries. So those batteries can provide the power you need in a small size. So these innovations can be used along with microchips, microprocessors, to produce something that's feasible for use these days for prosthetics. On the right-hand side are the Maxon Motors, which is a company well known for making very tiny, powerful motors. You combine those with microcontrollers and lithium polymer batteries, and you have a really great mechatronics robotic source for making and creating prosthetics. Now, how can we access these prosthetics? If you have a lower limb prosthetic, like a lower limb powered, externally powered foot that can control the resistance of an ankle for the foot to move up and down, that's tough to get to. So if you could use somehow your phone to access what's going on in your foot prosthetic, that could be a big benefit. So what they have currently is they can use Bluetooth. And there's a Bluetooth transceiver in your phone and a Bluetooth transceiver in some of these prosthetic high-tech devices where you can actually monitor your foot and see if the battery is getting low or not. And you can also turn your foot on or off. And you can also change the settings, because you also have in these feet lots of sensors, microcontroller chips, sensors that can record the force and the angles and the accelerations. But what if you could also control your foot or your upper extremity prosthetic from the internet? And this is really high tech. If you think about the IoT or Internet of Things, you may be involved with this yourself if you think about your home. Lots of homes have surveillance cameras. At my home, I have a Ring doorbell. And if someone comes by, the Ring sensor has a motion sensor that triggers the video to activate. It sends my phone a notice, so I'll know by my phone if someone comes to my house. And I can, through the internet or World Wide Web, anywhere in the world, know if someone's been ringing my doorbell. So if you could use that technology through the World Wide Web to access a lower extremity prosthesis or an upper extremity prosthesis, this is pretty amazing stuff. So if you're normally not wearing a high-tech prosthetic, you may want to see if your high-tech prosthesis at home is being charged or not. Or when you go home in the afternoon, you want to wear it when you want to go out. You could do that through your phone, through the World Wide Web. You could also see if it's being charged, if it's fully charged yet or not. You could also run a diagnostic test and see if it's charging correctly or if it's functioning correctly before you go home to even wear your device. If you're a research engineer or if you're a prosthetist like Chris, you could, from anywhere in the world, access someone's prosthetic, and with their help, you can see if their prosthetic is working correctly. So you could have the prosthetic patient working with you remotely and see if their prosthesis is moving correctly as they move. You can see if there's an issue. If the issue is maybe there's a drain in the prosthesis somewhere. So if there's a current sensor on board, you can see if a lack of functionality could be caused by a high current as opposed to a battery failing or a battery just being drained. You can see how the patient is articulating by angular sensors built into your prosthetic. You can see the forces involved with implanted forces in your socket. So if the socket is not fitting quite right, you can get that data totally remotely. The patient can be literally around the world, and you can get this information from them to help the patient and to help with your diagnosis. So to go full circle on this presentation, with Chris's presentation, the sky really is the limit for research and design engineering, and for prosthetists on how we can help the patient with disabilities make their life easier, not just at work, but at the workplace. Thank you.
Thank you so much, Brian and Chris. We're going to go ahead and move into our Q&A portion of the presentation now. So if you have any questions, feel free to send those in. And we've had a few already, so we'll just start firing those off. So we have one. I believe this is to Chris's presentation. People are using hobby 3D printers for making their own cheap prosthetics. What are your views on this? So that might be Brian.
Both.
I think it's both, probably both of us. There's a couple ways to look at this. I think if you look at it in the charitable part of it, it's fantastic. And so there's a lot of places around the world where people don't have access to medical care. Even places around the U.S. that we still don't have access to medical care. And it's great that these patients are being able to be fit with things. What I caution people at is that they, depending on the type of 3D printer that they're using, and if it is a hobby or home type 3D printer, those devices are not designed to print weight-bearing devices or devices that are supposed to last a really long time. So we have to be very careful with that. And if we're building devices attached to a human body, whether it's directly or indirectly through a socket, those are actually regulated in most states. And so if that patient was to get harmed or hurt using that device because you're not trained on how to make something, there's a whole legal implications to use with that. So for that side, it's concerning. But for the charitable side, it's really, really great. Some of these people are doing.
Fantastic. We have another question here. So are the implanted sensors getting the information from the brain that is telling the muscle what to do? Yeah, so there's two different kinds of implanted sensors that we can basically have. Ones that are external, or to the extremities, so say the muscles and nerves that are in an arm or a leg. And then there are implanted sensors that can be implanted into the brain. So as you could imagine, surgery towards the brain is a little bit scary, but it's the same type of technology as mapping which part of the brain or which muscle or nerve or segment controls different aspects of the body that are either there or not there. So yes, the sensor could be in the brain. That's the part that was controlling the hand or the arm or the leg or whatever part that we're trying to replace prosthetically. So great. Have another one here. With robotics becoming more and more advanced, are you concerned that a prosthetic could become too smart and a person could lose control of it?
Yeah, I'll touch base on this. So a lot of people watch the movies like The Terminator, And they think we're not that far off from having AI, artificial intelligence, and there's going to be robots roaming the earth, or that a prosthetic that has all these sensors and microcontrollers that you actually program and motors on board, that they could think for themselves. In reality, we're a long, long way off from any kind of artificial intelligence in prosthetics. It's really a simple loop that we're programming into these microcontrollers. The microcontrollers sense maybe a reactive force or an angle, and based on that input, they do a specific response. They'll make a motor turn so many revolutions. So we're way, way off from anything near artificial intelligence in a prosthetic.
Wow. And this, I think, actually kind of plays into that question as well. With, you were talking about the Internet of Things, and people being able to access prosthetics, specifically an engineer or something to see that feedback. Is there any possibility of hackers being able to get in through that type of technology?
Yes, and we have thought about that. Actually, currently we're designing something for oven use, because prosthetists require melting plastics for making orthotic parts and prosthetics. And what we're trying to do is make an Internet of Things remote access for a prosthetist to use his smartphone to turn an oven on and off. And there's a concern there if it's hacked. Someone could go and turn an oven on, and of course that's dangerous to have a heating device on in the home or an office. So there are very strict protocols we can go by in different layers of protection and codes and certain access codes that people have already thought of using that we can use to our advantage to make sure that these things are not hacked.
Great. Another question here. And this, I'm sure, is relevant to a lot of people. Are prosthetics often covered by insurance? And if so, if they're not, are they affordable for daily users or people who might not have that insurance?
Yeah. In general, prosthetics are covered by insurance. A lot of the new technology that comes out takes time to be covered by insurers. And by that, I mean there's technology that's been around for a decade that's been proven to be effective and useful for patients in multiple studies, that there are insurers who still do not cover those devices. And those are like the myoelectric hands that you saw that we kind of presented on. Some of the insurers deem those excessive and not necessary. With that to be said, is just like with any technology, things are extremely expensive, and that's more than likely the reason that insurers do not want to cover them, is because of the cost. And so a lot of these newer technologies, we're talking in the tens of thousands of dollars as far as costs to an insurer or to a patient. So we advocate for the best coverage for these devices, but that is a grander healthcare scheme act that I might not be able to answer for everyone.
Right. Something else that was mentioned was that waterproofing was kind of a barrier for a long time, and that you've been able to push past that barrier. Is there anything now that is sort of the new waterproofing? What other kind of barriers are you looking at now?
Yeah, the other big ones are the basically a sensation and control, the two other kind of things I talked about. Engineering-wise, we can, Brian and other engineers can pretty much develop and engineer anything we want. If cost is nothing and materials is nothing, and they can use whatever they want to do it, they could design devices very, very similar to the human hand, or to complete any specific job task, which might even be a whole better way to look at things, is to make prostheses more job task specific. But our ability to control them is really our and tell what we're doing is really our weak point right now. So we can program robotics to do a lot of cool things because we just simply write code. But once you attach them to a human, each human is different. So that's where our problems come in, is that one amputee might look like the other as far as where their limb is amputated, but the muscles that were left inside could be completely different. The nerves that are connected still could be completely different. The strength of those muscles could be completely different. And they change day to day as well, depending on how much they've eaten, what kind of fluids they've had. So the ability for us to control that and get those muscles and nerve segments in the brain to control a prosthesis is really our limiting factor right now. Mm-hmm. Surgeries like TMR, RPNI, implanted sensors, osseointegration are all at the infancy and are really going to see a huge ability to change what prosthetics looks like in the next decade.
And I would think that that Internet of Things, being able to access all of those motions and forces, really plays an important part in that, being able to change to the individual and all of that type of thing.
And like Chris said, a big barrier is cost. So it's tempting if you have a hobby-grade 3D printer to make maybe your own little prosthetic device. But again, the one that I have, I'm making prototypes, but they're not field usable. These are prototypes that I would just use in-house to test a concept, something I can get my hands on. So it's really, really beneficial to get a prosthetist like Chris involved if you need a prosthetic device.
Great. We've got a little bit more time here for questions. Another one that we have here is, do you have any favorite testimonials from individuals who've used these more advanced prosthetics?
Yeah, the biggest one that I have, and it's kind of a funny testimonial more so, is with the waterproof type devices. It's not the patient, but their wife says, now you have no excuse not to wash the dishes. And so it's one of those funny things that we take for granted, but then he has no excuse now. So his excuse, since they've been married, because she never knew him prior to his amputation, was he couldn't wash dishes because he can't get his prosthesis wet. And so he gets a waterproof prosthesis, and now he has to do the dishes. And you think about it, and we're in Tennessee, and another guy is washing his truck. You know, to be able to wash his own truck is a huge thing for him. He can wash his own truck. It's just things that a lot of people take for granted, simple things that water was not our friend to, that now they don't worry about. And so that's huge for those patients.
Right, and I'm sure that those small quality of life differences can make, a world of difference for someone.
Exactly.
Stuff that we take for granted.
I have 2 young kids, 2 daughters. How would I bathe them if I was an amputee? And I couldn't get a prosthesis wet. How do you hold a 2-year-old or a toddler in a bath? It's not possible if you can't get a prosthesis wet and you don't have 2 hands. I wouldn't want to try it with 1 hand. It's hard enough with 2. So we're really taking and eliminating as many boundaries for these patients as possible.
And what's great about that is that's a personal connection as well. You're creating experiences and personal connections that are so crucial and important that wouldn't be there if it weren't for those things. Right.
And we coming back to the cost things, and I tell people, yes, these devices are expensive. A waterproof prosthesis, you could look at $50,000 easily for a prosthesis like that. But what is that worth? What is it worth to be able to live a quote unquote normal life, if you want to say that and use those words? Bathe your child, garden, water plants, dig in the dirt, things like that. What is that worth to you? And to each patient, that's something different. Some may say $50,000 is not worth it. Some may say 50, I'd pay $1 million. And so that's where it gets hard to answer those cost kind of questions.
Right. It is really just about living a normal, a life that is that is to its fullest.
Yeah.
Right?
Yeah.
Another question we have here is, what's the future of app development in conjunction with prosthetics? If that's something that maybe you're not specifically on your end, but something that you might be aware of.
Well, there's lots of apps already for Bluetooth. For example, we have a prosthetic foot called the Raise that has a Bluetooth transceiver on board. And like the earlier picture I showed, you can have your smartphone communicate through Bluetooth to turn the foot on and off and check what the power level is and control different functions. But I think the future is really going to be with the IoT, the Internet of Things, because your phone, of course, has Wi-Fi built in too. So if you have a Wi-Fi transceiver built in, and again, everything is getting really small these days, micro electromechanical systems, MEMS. If you can put all these devices into a foot or upper extremity, then you can really make some interesting apps where you can really control anything from anywhere in the world with web accessibility.
Yeah, it's I tell people the limit of Bluetooth is distance of which I can be controlling things. So I control and I program a lot of the devices that we see there through Bluetooth in the office. The second the patient goes home, I cannot access that Bluetooth. It's too far. So through the internet thing and apps and things like that, a patient could tell me they have a problem through a video chat similar to what we're using here or any other kind of means. I could look at that device or what's going on, and I could see the different sensors, and I could adjust a setting. Right now with coronavirus and everything going on, we were limited by healthcare and what we could see. It's like a perfect time and talking about it is a patient wouldn't have to come in. They could simply make an appointment, a virtual appointment. I could log into their device. We could see the same things, and we can make adjustments on the fly, which is a really interesting kind of thing that we haven't had the ability to do.
That's fantastic, and that type of thing can really keep the cost down as well. Having to pay for that appointment instead just meeting virtually. I think that we're getting close to the end here. We've just got a couple more minutes. Is there any sort of parting words you might want to say about the future with PhilHour, or anything that you're excited about, just as a little sign off here?
I'll just say that I just want to say thank you to everyone for listening and the opportunity to present here. And the next decade or so is going to be amazing. A lot of the stuff that comes out is going to be extremely interesting, and it's going to, depending on how we adopt it as a healthcare nation and what we do, is going to be what is our limiting factor. So, like we said, if you dream it, we can make it. We're at that point almost. It's kind of crazy. So.
Yeah, thank you to Signal Centers. And like Chris said, it's really the sky's the limit. We have all this technology. It's just a matter of harnessing it the best way to make life easier for people with disabilities, in this case at the workplace.